Picture the scene. Tropical island. The sun pounding down into beautiful clear blue waters. White sand under your feet. You're sitting under a palm tree, listening to the wind and the waves and nothing else. Perfection. You order a drink from the beachside cafe. Something cold and fruity and full of ice. Before taking that first sip, you gaze into your glass and you start to wonder what is going on. The ice is floating in your drink. And yet, you've always learned that solids are more dense than liquids, and so it should sink. Understanding this strange property of water is very important for your drink by the beach, for chemistry in general, and perhaps, most importantly, for polar bears. Let me explain. This is Thing 4. All matter is made up of atoms. All atoms have electrons. The movement of electrons causes forces to occur between individual atoms or complex molecules. This force is called a London dispersion force, or LDF for short. LDFs are formed through the uneven distribution of electrons in an atom, or how electrons are dispersed, hence the name of the force. Let's use bromine as an example. If many electrons in bromine happen to move in the same direction, a temporary dipole will be formed, a situation where there is a negative and a positive side. When this randomly happens in one molecule of bromine, it will induce a dipole in other nearby molecules. The attraction is a London dispersion force. London dispersion forces explain why non-polar molecules are able to form liquids and solids. But remember, they're also present between polar molecules. However, they are the weakest van der Waal force. If we now move into thinking about the attraction between polar molecules, we're going to come across the permanent dipole force. Taking a molecule like hydrogen chloride, where the chlorine is more electronegative, a permanent dipole is formed in the molecule. The chlorine part of the molecule will be slightly more negatively charged compared to the hydrogen part. This is true for all the HCl molecules, and so a force is formed between these permanent dipoles. The partial negative charge of one molecule is attracted to the partial positive charge of another. Due to this being caused by a permanent dipole, the force is stronger than LDFs, which are due to temporary dipoles. The other force that you have to be aware of is the strongest of the three, hydrogen bonding. This type of bond is mentioned a lot through the higher chemistry course. It is formed due to the large electronegativity difference between hydrogen and either nitrogen, oxygen, or fluorine. Using water as an example, H2O, the oxygen will have a big partial negative charge. This will be attracted to the partial positive charge of another water molecule. It is important to remember that hydrogen bonding is not within the molecule, rather it is the force between the molecules. This tiny force at work between water molecules dictates so much. Without the force, ice would not float. Whole ecosystems that rely on the surface of frozen water could not exist. Ice would not reflect sunlight at our poles, reducing global warming. Floating sea ice would not contribute to patterns of ocean circulation and weather patterns, and act as sources of surface fresh water and nutrients needed for the growth of phytoplankton, the basis of marine food web. May the intermolecular force be with you on the beach, and more importantly, with the polar bears. They need it more than anyone. This was Think 4. Thanks for watching.